Hello and welcome. This is a Unit 1 boutique solver program for Physics 1020. We're going to go over this. This is basic kinematic stuff and unit conversion. So without further ado, we've got three items here in the main menu. First one, bowling ball has a density of 5.5225 kilograms per meters cubed. What is the density in grams per centimeters cubed? So this is going to be unit conversion. And then this is density. It doesn't all fit here, but hey, this is kind of made on the fly. We do density conversion. And then the initial density, we want to make sure we enter this carefully. 5.5225. There we go. And then it looks like the answer is 0.0. Looks like they want three digits after the fives. Oh, that's exactly how many we have, right? Okay, perfect. Okay, fantastic. That one just worked out serendipitously. Okay, now cheetahs traveling at a speed of 34.173 meters per second. What's the speed in kilometers an hour? So there's going to be a speed conversion here, option 2. And then meters per second, I think, is the 34.173. And then cool, we get 123.0228. And it looks like, okay, we got 302. Okay, so it looks like we're going to 2 decimal places right here. So that's just going to be 123.02 kilometers an hour. You do want to pay attention to that. I'm more of a math guy than a physics guy. So I'm constantly like not labeling units, bad habit of mine. And like rounding is, I don't know. I guess I'm no longer good at math and science. Okay, so next one. We got a volume conversion. I know this is number 3. It's going to be meters cubed to centimeters cubed. So the volume is 1.3211 meters cubed, and it goes to, okay, 13.21100. And I think, okay, that's all we wanted. So centimeters cubed, everyone's happy. And I like to circle the answer so professors or teachers or instructors know what's going on. Okay, bear with me. Okay, that was pretty fast. Cheryl walks a distance of 20. I'm going to zoom in a little bit. 24.76 meters with an average speed of 1.5977 meters per second. How long did it take her to walk this distance? So this is what they call a basic kinematics thing. It's just stuff moving without resistance. It's option 2 here. So it's going to be the time calculation. Okay, and then what is the distance? It's this right here, the 244.76. And then the velocity. Velocity and speed are interchangeable. Don't tell your math or your physics prof that. They're going to yell at you. But it's, for most human beings, it's the same thing. Okay. How long did it take her? Okay, we're going to go 153.195. It looks like it's going, there's the decimal place. We're going to go 2 after the decimal place. So look, they call this a trailing digit. Since it's 5 or greater, we're bringing that 19 to a 20. So it's going to be 153.20 seconds. Okay, good. Now I'm going to zoom in a little bit because I have older eyes and I can't see everything. So so this next one, starting from rest, a runner achieves a velocity of 4.4878 meters per second, a time of 3.3721 seconds, which is the average acceleration. So this is going to be an acceleration calculation because we want to know the acceleration. I tried to label them so it makes sense to people. Now the initial velocity, okay, when it says starting from rest, that means initial velocity, v sub 0, is 0. So I'm going to put 0 here. And then what's its final velocity? 4.4878. And then the time, 3.3721. There we go. So we've got 1.33086. I know we're not going that far. We're just going 3 digits after the 3. So we're going to go this. But again, okay, so this trailing digit, right? This 8 is 5 or larger, so I got to bump that up by 1. So it's going to be 1.331 meters per second squared. Okay. Let's see. Okay, question 6. It barely fits in the frame. I apologize. A car traveling, and I'll move this a little bit. I can't move it. Dang it. Okay, car traveling in a straight line with initial velocity of 14.790 meters per second undergoes a constant acceleration of 2.0868 meters per second squared for a time of 3.06282 seconds. Sorry. How far away from its starting point is the car at the end of this time? So this is the distance with acceleration. Number 3. Initial velocity. Okay, it is that 14.790. You'd have to put the trailing zero. That's not a big deal, but if you do, that's okay. Constant acceleration, it's positive, 2.0868. And time is 3.0682. There we go. So 55, and it looks like we're going with 3 decimal places, 20109. Okay, so this is cool because we can just make it, oh, sorry, that's a 1. So 55.201 meters. Okay, good. We're halfway through this. Okay, we're making good progress here. Okay. And again, I apologize. Everything's barely fitting, but I need it to be huge so I can see. Car moving with initial velocity of 55.446 meters per second slows down to a constant acceleration of negative 5.3359 meters per second squared. What's its velocity after this deceleration? So it wants to know its final velocity, which is option 4 here. So initial velocity, that 55.446. Acceleration. It's a deceleration, by the way. It's negative. So look, this is the negative symbol here. Negative key below the 3. 5.3359. And then the time, 1.9916. We're all good. And we get 40. I'll go to a darker color for writing this. 44. And it wants to go 3 decimal places. 819 meters per second. Okay, great. Oh my gosh. We're more than halfway through this test. Thank goodness, man. Okay. Ball is thrown upward with initial velocity of 20.161 meters per second. What's the ball's velocity? 3.9291 seconds after it's thrown. Now check this out. Technically, this is also a final velocity question. Now the acceleration. So for most people, okay, if you're in AP physics, don't hate me. The acceleration due to gravity. So I should say like A sub G technically is going to be negative 9.8. That's for most people. Sometimes do negative 9.81, sometimes negative 10. Okay, so I'm just telling you that. So if you have a different kind of question, don't blame me. You realize acceleration due to gravity is different for every class. I'm not kidding. Initial velocity, 20.161. You think you'd have like universal agreement on acceleration due to gravity. We're going to put negative 9.8. Remember, that's a negative. The time is 3.9291. Okay, negative 18 point, and we'll go 3.344. Cool. The trailing digit here is a 1, so we're cool with keeping it that way. Meters per second. Now, what does this negative mean? It means it's going towards the Earth. It's going back to you. So you throw it up at 20.161 meters per second. It's coming down at that moment, 3.9 seconds at 18.344 meters per second. That's what that negative velocity means. It's not going up, it's coming down. Okay, now this next one. I think this is projectile motion. That's my guess. So the height, okay, cool. The height, 12, we're just going to enter it as here because you guys have already been through enough of this. You kind of figured it out. Horizontal velocity, 5 point, and I'm sure you can read the numbers, 6561. You could just zoom in and stuff. 5.6561. Okay, just want to make sure I get it right here. Gravity again, negative 9.8. We're just gonna leave it at that. Okay. Whoa. How far? I get an I here. That's a little funky. Oh my gosh. I probably have like a negative thing going on here. How many digits? So it's 3 after the 0. This, again, the trailing digit here is a 6. That's going to bump this up to a 6. So 9.0516 meters. Oh my goodness. Okay. Now, number 10. Now we're back to normal stuff here. This is going to be dynamics and forces because we've got forces acting against each other. What is the mass of the box? That's going to be net force and mass here. So look, force 1. This is going to be positive. Going east. Going east is positive. So that means going west is negative. So accelerating east, this is going to be a positive acceleration. So just kind of keep that in mind. So force 1 is 59.499. And since force 2 is opposite direction, we're going to go negative. So it's negative 20.623. And then acceleration, that is a positive 4.4788. Oh, there we go. So we got 8.68. We got a whole bunch of zeros, so I'm not even worried. Kilograms. Let's see, we went 3 after the 6, so that's like, so 8.6800 kg. Okay, great. Oh my gosh, 2 left. Awesome. Okay. Oops. Okay. Next one. Trying to get it. Okay, whatever. I'm trying to get it all on the page here. Number 11. Tension. Okay, so this is tension and acceleration. Option 2 here on the dynamics and forces. The tension, and I don't think you need to be walked through what the numbers are. I hope you can read them. 19.259. The mass is 1.4434. Gravity, negative 9.8. So okay, cool. We get a regular number again, 3 point, and it wants 3 numbers after the 5. So it's 428. Okay, that works out perfectly. 5428. Because the trailing digit after the 8 is a 0, so we don't have to do anything to it. Meters per second squared. Oh my goodness, the ultimate question. Okay, good. Now, this one, normal force, I'm assuming is an elevator. The mass, 59.307. The gravity, again, we're going to do negative 9.8. I might have messed up in the program. If you start getting I's as answers, blame me. Acceleration is 1.276. Accelerating upward, so we're going to go like upward is positive, downward is negative, just so you understand why the force of gravity is negative. So 656.88, because the trailing digits of 4, we don't have to do anything to it, newtons. Okay, great. If you like this, like it. If you dislike it, hey man, give it a thumbs down. It's okay. But then comment if you want to see other stuff. This is like a boutique program I made for a student who's bought physics program. She's like, hey, help me out. This is my unit 1 retake. What do I do? And I'm like, oh my gosh, you don't need the full physics program to do this. So I made her a small boutique one. So look, if you have questions like this, let me know. Comment, or you can go to the mcstutoring.com site to get the big PhysSolve program. If you're taking AP Physics, oh my gosh, we've got you set up. If you're taking AP Chem, oh my goodness, you need to get down there because we've got activity series and common polyatomic ions. I just added a bundle to the chemistry. So if you want to get first and second semester chemistry, you can get it for $95, less than $100. Okay, so take care. Subscribe if you want. Hope you have a good day. Okay, bye-bye.